Welcome back. Today's my assignment problem to discuss is prohibited assignment problem, or it is also known as constrained assignment problem or conditional assignment problem. Prohibited means when there is a restriction imposed by the management not to allow a particular job to a particular machine or not to perform on any particular machine by any particular worker. So it is the condition imposed. Sometimes the data is given in full form and condition is written. If the condition is written, it should have been worker 1 cannot operate on machine 4 and worker 2 cannot operate on machine 3. This is a statement. The problem, sometimes the matrix is full without any dash, and sometimes the statement is given that so and so worker cannot operate on so and so machine. Then you have to delete that number and put this dash. So this is the condition, this is the constraints, this is the prohibition that a particular worker cannot operate on a particular machine. Secondly, in any type of assignment problem, you have to check 3 points mainly. Number 1, whether it is a minimization case or maximization. If it is a minimization case, proceed further. If it is a maximization case, then convert it from maximization to minimization. And secondly, if it is a balanced problem, that number of rows are equal to number of columns, or number of columns are equal to number of rows, are not equal to number of rows, then you have to add dummy, because it must be balanced one. It must be balanced one. So balanced, and if it is a maximization problem, then convert it. If it is unbalanced, then make it balance. So this is cost matrix. So there is no need of conversion. We will convert it into balanced problem. There is a less number of workers, more number of machines. So we will add dummy row, that is 4th worker. Say W1, W2 worker, 3, and W4 is dummy worker. And 4 machines, M1, M2, M3, M4, and this dummy worker will be added with 0, 0 element. That is row, additional row with 0, 0 element, 12, 4, 8, then 3, 11, 2, then 6 dash 10, and then dash is here 5 and 9. So there is no need of column reduction, but we have to go for row reduction. For row reduction, this is dummy, M1, M2, M3 and M4. The minimum element is 3, it is 9, 0, 3 dash. And here minimum element is 4, 0, 7, dash 1. Here minimum is 2, 6, 0, 8, 7, and this is the dummy row. Now go for assignment. Find the row in which there is single 0. This is assignment, cross other zeros. Here again single 0, cross other zeros. Now 2 zeros. Now go for the column. In this column there is a single 0, go for those. So number of assignments are 3, but we want number of assignments as 4. Then we have to go for marking of rows and marking of columns. Then we will draw lines. Marking the rows, find the row in which there is no assignment. This is a single row in which there is no assignment. Then mark the column in which there is 0 in the marked row. Then mark the row in which there is assignment in the marked column. So further marking is not possible. Now draw the lines through unmarked rows and marked column, unmarked rows and marked column. Select the minimum element. Next is select the minimum element is 3. Subtract it from all the uncovered element, add it to the elements lying at the intersection of two lines. So here 3 means 6, 0, 0, dash, 0, 7 lies at the intersection of two lines. We add 3 to 7, 10, dash, 1, 3, 0, 5, 4. We are subtracting 3. Now 0, 3, 0, 0. So this is your this is 4 dash, that is dash means dummy, and this is machine 1, machine 2, machine 3, machine 4. Now the table is ready, matrix is ready for assignment. So for assignment, find the row in which there is single 0, 2 0. This is single 0, cross it. Then single 0, cross it. Then 2 0. Then come to the column 2 0. Here is single 0, cross it. Here is single 0. Make this assignment. Now assignments are 4. So we get the result. Because number of assignments are equal to number of rows and columns, so this is the optimum result. From optimum result, we have to write down the answer or the result of our assignment. This is workers, machines, and it is cost. So here W1 worker should be given machine, should operate on machine 3. W2 worker should operate on machine 1, and W4 worker, 3 worker, it should be 3. It is 3 dash. 3 on machine 2, and W3 dummy, it is dummy worker. Actually there is no worker, and this should be given dummy machine, machine 4. So this is no allocation. W1 at M3, W1 at M3, the cost will be 6. W1 at M3, then W2 at M1, W2 at M1 11, and W3 at M2, it is 2. So this is no cost. 19 will be the minimum cost, and this will be the optimum answer because further cost cannot be decreased. So this is your prohibited conditional assignment problem. Sometimes condition is given, so worker and cannot operate this area, the machine or job particular cannot be operated on this particular machine. So technique is the same. Technique is always a Hungarian assignment method. So this assignment you have to solve as per Hungarian assignment method. So I think this is very simple way of solving if it is prohibited, because condition is always whether it is minimization or maximization, whether it is unbalanced or unconditional. So I think it's okay. I think you have followed it. Thank you very much. Kindly like my video, share and subscribe, and put your queries or any question on my YouTube channel. It will be my pleasure to solve your problems. Thank you very much.